Let's see how Trig applies to these journey paths. So we've got ourselves a journey. Let's say that we've got some emergency. We get a phone call. We've travelled all the way out on these 3 legs of the journey. We get a phone call and we have to get back to where we started as soon as possible. So we want a direct line back, and we need to know the bearing that we need to travel on to get back to the beginning. So the way that we can do this is we can split up each of the 3 components into their north, south and east, west components. So let's start with the black one. So I have got that black part of the journey where I'm travelling 3 kilometres. I've got a north-south component called B and an east-west component called A. And by using Trig, I can figure out that sine 54 is the opposite over hypotenuse, cos 54 is adjacent over hypotenuse, and I get those 2 values. So now I know that it's 2.42 kilometres east and 1.76 kilometres south. Now that I've got my black section figured out, I go on to the blue section, and that's the easiest one because there's no north-south component. It's pure east-west. I'm done there. I can move straight on to the green one now. The green one has got a north-south component. Cosine 28 is equal to that north-south component over the hypotenuse 2, and so multiply the 2 across and I get 2 cos 28 degrees, 1.77 kilometres. Likewise, I can use sine to figure out that it's 0.94 kilometres on the east-west component. Now that I've broken up all 3 stages of the journey into north-south and east-west components, I can just add or subtract them to get the total. So starting with the north-south, I've got that 1.76 in the black triangle and the 1.77 from the green triangle to get a total of 3.53 kilometres that I travelled to the south. For my east-west, I've got to add the first 2 and subtract the last one because it's going back towards the west again. I get a total distance of 2.2 kilometres east of my starting point. So now I'll clear this up and just draw the big red triangle. I won't worry about the other components anymore. We just have that 2.2 and the 5.3. And what I want to know now is I'm starting in the bottom right. I want to know how to get back to the start. So it's that angle theta down there in the bottom right corner that I'm interested in, and the distance that I have to travel that I'm interested in. They're the 2 things I have to figure out. You'll notice that I'm basically heading northwest. I just need to know the exact angle to finish that off. So the first thing I do is to figure out that angle. I use the 2 sides that I've just calculated, and I'm going to do inverse tan of the opposite over the adjacent, and I get 60 degrees in 13 minutes. To find out the distance that I have to travel, I could use Pythagoras, and that'll give me 4.07 kilometres. I could have also figured out the distance using trigonometry. So for example, I could use sine or I could use cosine, either would work, but sine of the angle is equal to 3.53 over d. Do a little bit of algebra and I get exactly the same answer as I got with the Pythagoras. Okay, now I've got all the information I need to know. To get home, I have to go 4.07 kilometres, and that 60 degrees and 13 minutes I can put as a conventional bearing as north 60 degrees 13 minutes west. So as you can see, there's a lot of work to do in getting one of these journey paths finished and done correctly. To get them done correctly without making any mistakes requires a really good diagram. The second thing that it requires is for that diagram to be fairly big. If you start off with a small diagram, by the time you've got all of those different sides and calculations in there, it's just a mess, and your chances of getting through it without making a mistake are pretty slim. So I'd be talking about half of a page. I'd be using ruled lines. I'd be trying to color code it like I did. anything I could to make what I'm doing clearer to myself so that I don't make any mistakes. But apart from that, it's just sine, cos and tan, as we've been doing over the last few sets. So just take your time, do it carefully, make sure you set it out in the diagram fully.